still being recorded. Okay, so now this is what I was explaining. I was saying, if you are given that slice of bread and your mom says, share that with your little brother, try to cut it that way. You will see what's going to happen. Why? Because this is not an axis of symmetry. So that's all that I wanted to explain in today's lesson, in addition to what we discussed yesterday, an axis of symmetry. I'm pretty much sure that you won't forget that. So now, number 3, let's talk about a hyperbola. Let's talk about a hyperbola. So we said the general formula is y is equals to a over x. So you will realize that the format of these formulas are different, completely different. We've discussed straight line, we've discussed quadratic, we are now on hyperbola. And we said this is what determines how your function will look like. At all the times, a function is drawn on a Cartesian plane. And we said if your a value is positive, you're going to have your function in those quadrants. If you have your a value being negative, you're going to have your function in those quadrants. Meaning, if you have, for example, y is equals to 2 over x, can you see your a value is positive, which means you're going to have your functions, your function in quadrant number 1 and quadrant number 3. If, for example, you're having y is equals to negative 3 over 2, all of that divided by x, can you see your a value, which is a fraction, is negative, meaning your function is going to be in the second and the fourth quadrant. Guys. In addition to what I've explained yesterday, this is what I want to make you guys aware of. What we call the vertical and the horizontal asymptote. The vertical and the horizontal asymptote. What are those, Bantu Bagiti? I'm just not sure of what nickname I use the horizontal asymptote. So, this is what happens under hyperbola. This function is just 10 adults. I explain all the stages of the functions. But when I say it is at a baby stage, it means this is where it started. And then it grows to become something which may look a bit complicated, which is a being equal to a o x plus b plus q. The difference between these two is that here next we added P, and then in the end we added Q. That's all. So this P and Q are the ones that give us the asymptotes. So P, it is the one that gives us the vertical asymptote, and then Q, it is the one that gives us the horizontal asymptote. I say because it affects one. So I normally refer to ghost yes. In our lesson, the moment we talk about the ghost Cartesian plane, I'll be talking about the equations of asymptotes. Let's see.
Like you are cutting, I can't hear you very well.
This is Cartesian plane, not the ghost Cartesian plane. This is the Cartesian plane. Let's say you have an equation being y is equal to, let's say, 2x let's say minus 3 plus 2. So it means negative 3 be related to and so be referred as y. So you use to the plane would be some is same for everyone.
You are cutting, Anna. You are cutting. I don't hear you.
I need someone to just confirm if it's on your side.
You cutting, sir?
It's breaking for everyone.
Yes,
Yes, sir.
Yes, sir.
Minenhle, is it worse?
No,
no,
sir,
it's
it's better.
yes, sir.
Okay, so this is what I was saying. These two values for P and Q are the ones that give you those ghost Cartesian plane. So how does a Cartesian plane, the ghost one, looks like? So can you see this value of 2, you plot it as it is. Can you see it's positive 2 and not negative 2? So that means you're going to plot it there on where y is 2. Literally. Remember to mute your mic, honorable member. Order, honorable member. Okay, so now can you guys see this is positive 2? So this is how you plot that ghost. Obviously this is going to be the horizontal asymptote, but when it comes to this one for P, if it's negative here, then it means you plot it in the opposite sign. So that means this one of P, there, can you see, there it is negative 3. So that means it is actually 3 when you plot it. This one, which is positive 2, you just plot it as it is as 2. That is why I plotted it there as 2. So that means this one, which is negative 3, you're going to plot it as positive 3. And then you plot it there. So these are what I refer to as the ghost Cartesian plane. What makes the ghost Cartesian plane, or what actually happens, or where are those coming from? So this is what they say. They are saying if you are having an equation being y is equals to just a over x, they say those ghost asymptotes, they are there. Here, there's one which is 0. There's another one here which is 0. So that means they are hidden inside that and pass through where that is 0. So they are actually hidden inside.
Sorry, so I have a question.
Okay, sengibuyile manje, right. So this is what I was saying. Those are there, but they are hidden. They are there, but they are hidden. That's if you are dealing with that at a baby stage. But now, if you are having y is equals to, let's say maybe 3 over x plus 1 and then minus 2. So that means the asymptotes, p is going to be in the opposite sign, which is going to be negative that. And then q, you take it as it is as 2. Then when you plot those asymptotes, you're going to plot this one at where x is negative 1, or there, let's see, this is negative 1. Then you are going to plot it there, where x is negative 1. And then this one of 2, it is for y. This is for x. So the one for 2, no.
Isn't 2 like a negative?
Yes. I was about to just say, I noticed this 2 is actually negative there. So you need to take it as a negative. It's only this one that changes its original sign, which means this one of negative 2, it is going to be somewhere there. So remember, guys, everything that I'm saying is going to make a perfect sense when we start dealing with exam type of questions. So what we are doing now is just to discuss all that you need to know under the functions. So now let's move on to this one of exponential function. So generally, an equation of an exponential function is just y is equals to b to the exponent x. Someone might be wondering, how am I going to know which one is which? I'll just make sure that before we go into the questions, we try to check the difference between those formulas or those functions to know which one is which and how do you notice which one is which. So most importantly, guys, they say as far as exponential is concerned, that b the b value will always be greater than 0. And again, that b value will never be equals to 1. So that means you can have something like y is equals to 2 to the exponent x. You can have y it's equals to what else? Maybe, let's say 3 over 2 to the exponent x. Why am I saying this? Is because this value is actually 1.5, and 1.5 is bigger than 0. So that means you will never have y is equals to 1 to the exponent x, for example, because they're saying your b value will never be equals to 1, and it will always be greater than 0. So that means it will never be less than, meaning you can't have -2 there to the exponent that, because this value is not bigger than 0. That's all that you need to be aware of. Someone already noticed that also here we are going to have that a value. So Moleboge, this is what I used to do let's say baby stage, teenage stage, and say adult stage. So this is how I did functions last year, and there's a reason to that. There's a reason why I'm not using this approach for now or at this stage. That time will come, but I just want to give you guys a background. This is what you study in grade 10. So that means at a baby stage, nothing is complicated there. You just have y is equals to b to the exponent x. So when you get to teenage stage, that's where things get a bit complicated. But not that much, because you are still a baby, but the only difference is that you are having an a value attached to your babyness. And then from there, you get to an adult stage, which is still your babyness, your teenageness. If there's such, then we add Q. So these are the three stages of functions. The same can be explained for straight line, quadratic, and hyperbola. I'm just giving you a background of how that works. So that means this is normally what they teach you in grade 10, and it might still not make sense in grade 10. When you get to grade 11, this is what they teach you. When you get to grade 12, this is what they teach you. So what happens is someone is not serious in grade 10. Not on purpose, but because they don't realize that they need to, so that they prepare for this too. They get to grade 11, they just pass for some reason. They get to grade 12. And then now you are in grade 12 and you realize you need that matric certificate, and you try and start being serious. But guess what? You are always lost, because you don't know, Mzozozo, where all of this is coming from. Your problem is not here, but it is there, which is the starting point. So that means you need to study everything. Not just study, but restudy everything in grade 10. Give yourself a week to go through everything for grade 10. Give yourself another 2 weeks to go through grade 11. I'm telling you, that's when everything is going to make sense. But if you always ask, when is the grade 12 lesson, you might always get confused or just absorb everything to your temporary memory. And if a question comes differently, you're not able to answer because they still include the tricks used in these two grades. And it makes things worse. So what happens is, Monday, I only focus on grade 10. I think Wednesday, 11. Friday, 12. Tuesdays and Thursdays, that's where we discuss everything in relation to maths. So that is where 10s, 11 and 12s must attend, which is today's lesson. So that means I'm refreshing your minds on everything that you need to be aware of, so that when we solve for exam type of questions, you know everything that you need to know. The problem is not knowing what you must know, and also not knowing if you know enough or not knowing if you know everything. So that is why it is important that you must not miss any of my lessons, because all the tricks that I'm applying are based on everything that I explain in all the lessons. So for now, let's quickly go through those. So an exponential type of a function on a Cartesian plane, again, Bantu Bakit, which has the x and the y. It's something similar to that or something similar to that. That's how an exponential function looks like. Just that. Or just that. So now, what is the impact of b? This is what they say. I'll just remove that so that you guys are aware of what is the impact of those letters. Obviously, A, B, A, and we'll get to Q. So what happens is they're saying if B is greater than 1, you have what we call an increasing function. Sometimes if it's given to you like that in a textbook, it doesn't make any sense. But the moment we say, as an example, y is equals to b if it's greater than 1, that's if maybe, for example, you have 2 to the exponent x. And when they say you are having an increasing function, they say on a Cartesian plane, your function will look like this. Can you see? It's increasing. Look at how it increases. Can you see how I'm drawing this? It's increasing. You start from left, going to the right in that increasing trend. That's what this means. But now, if the b value is less than 1, let me quickly make sure of that statement. Not b being less than 1, but remember, we said b can never be equals to or less than 1, but it will be greater than what is it? 0. So that means if b is between 0 and 1, I want you guys to be aware of something. Every time when something is written like this, let's say maybe who's on the line, K, if something is written like that, it means between. It means K is between whatever and whatever. So if you have X, that and that, that means X is between. The moment you put values there, if you put 2 and 4, it means X is between 2 and 4. That is what that sign means. So now, this one, it means if B is between 0 and 1, An example, y is equals to, I think 3 over, no, not 3 over 2, but let's say, for example, 1 over 2 to the exponent that. This in decimal is 0,5, which is between 0 and 1. That's what they mean when they say a value being between 0 and 1. Normally, that's when you have a smaller number as the numerator and a bigger number at the denominator. As the denominator, you're going to get 0, something. So it's more like b as a decimal. If it's 0, something, you have a decreasing function. How does a decreasing function look like? Remember, when you draw an exponential, you start from left to right. So this is how it looks like when it's decreasing. Can you see? From the top going to the bottom. That is a decreasing function. This is an increasing function. So I think for now, let me not go deep into that one. And but maybe let me also quickly explain the a value. I just remembered that I wanted to explain all those stages. So that means the a value, it has an impact on the steepness of that exponential function. What do I mean by the steepness? So the steepness, can you see? If you have an increasing function, look at how steep that is. If you want to imagine the steepness, think of yourself walking there. Can you see? To walk there, it's going to be difficult. It's going to be very difficult. But you can easily walk maybe nicely on this one. Can you see? It's not really that much steep. So the steepness of a function is influenced by that a value there. So you might find that the bigger the value, the steeper it gets. The less the value, the gentler it gets. So that means you can sketch a function where 1 is 2, maybe times, let's say 2 to the exponent x. You sketch another one, let's say maybe here is 4, then you have 2 to the exponent x. You sketch 1, 2, and check between these two which one is deeper. And then you can make a conclusion to say, if this a value is small, maybe it's gentle. And if it's bigger, it's deeper. That's how you do a maths investigation, where they say investigate if whatever. So that's what I've discussed, the A and the B impact on a function. So now let's talk about the Q. Literally, in all the functions, the Q has an influence on the vertical shift. Remember, the vertical shift, I'm not talking about the upward shift. It is the up and down shift. If you have a, let's say y is equals to maybe 1 over 2 to the exponent x, maybe let's say plus 1. This plus 1, it means it has shifted 1 unit upwards. If it was a negative 7, it means it has shifted by 7 units downwards. Just always remember that this it only refers to the vertical shift. So that's all that I had to quickly take you through. I wanted to make it a summary, but it seems like it wasn't a summary, but it's fine. That's how you learn. When you are being told or explained something over and over again, that's when it makes some sense. So now, this is what I'm going to quickly do. Let's go into that group and look for that question. Let me quickly access that question in there. But otherwise, up to this point, can you guys still be able to hear me? Because we are about to get to that point where we will need to engage. I did not want to be interrupted because I was just doing a repetition of what we have done yesterday. So I had to make sure that I explain all that I wanted you guys to be aware of without any interruption. So let's see. Okay, this is where it starts. Can you guys see that first question, question number 4?
Yes.
Yes.
Okay. Question number 4, let's try to discuss all of that. I think because of time, what we're going to do is just to discuss those questions and not really solve any question. And then from there, starting from tomorrow, that's when we'll be solving for some questions. So all this information is enough for you to solve any question related to functions, whether in grade 10 or 11. So let's now try to have a look. We are given f of x. Can you guys see? This is now given in a form of a statement. We don't have a drawing there. So that means you should expect anything in any form. But most importantly, guys, they are saying f of x is equals to negative 2x squared plus 2, and g of x is equals to 2 to the exponent x plus 1 are defining equations of graph f and g respectively. So you no longer worry about what f is or what g is. It's just the name of a function. But what you should ask yourself is, what type of functions am I having there? Which is what I wanted to quickly explain. Y is equals to mx plus c. This one is a straight line. And then this one of y is equals to x squared plus bx plus c, or maybe let me just keep it to that standard of x squared plus q. This one is parabola. If you want to know what makes that to be a parabola, just look at the position of x. Can you see? That x is to the power of invisible 1. That is why it is linear or straight line. This one, it is to the power of 2. We said anything to the power of 2 is quadratic. Look at this one. You're having a over x. It doesn't matter whether you are having plus p there and then plus q there. But what matters the most is that x is at the bottom. And for that reason, it makes it to be a hyperbola. But now, look at this one. You are having, let's say, b to the exponent x. It doesn't matter if you still have q there. Can you see? In the power of an exponent, you are having your letter x. So that's what makes it to be an exponential function. So what I'm saying is, you need to be aware that now you are dealing with a quadratic and an exponential. So that means this is what you are going to need. You forget everything about hyperbola, you forget everything about a straight line. So just make yourself load shedding under straight line, make yourself load shedding under a hyperbola, and make it stage 10, please. So now we will switch on those two. So that means everything that you need is in there. Let's try to quickly have a look at remember, guys, I said in mathematics there is no time for qua. We don't waste time laughing in mathematics. You just say achi or ha, then you're done. You will finish the laughter tomorrow morning when you wake up. So let's see. 4.1, what are we having there? They are saying write down an equation of the asymptote of G. Can you see, Moleboge? Now, this word asymptote, it's not a new word. It was discussed when we started with this lesson. But guess what? I might have not explained how you get an equation of asymptote for an exponential function. And this is what happens. It's not explained in grade, let's say, 11. Maybe it's also not explained in grade 12. On assumption that they think you know. And it comes in exam, but you can't answer that question. That is why it is very much important that when you study maths, you study everything. There is no such a thing called grade 10 maths. It actually limits your ability to think to a limited extent. The brain is such a powerful tool. The more you study ahead, the more you understand things better. So don't limit your thinking capacity. So what I'm saying is, the word asymptote, you are not hearing it for the first time, but you might not know what that is as far as an exponential type of a function is concerned. And most importantly, it is allocated 1 mark. So I will discuss that when we solve for this problem. So Mbali, this is what I always say. In most cases, especially those who are not having an opportunity to attend extra lessons, you go to exam not knowing everything that you need to know. There are some who goes to exam with 60% worth of information. So that means already they go in exam with a loss of 40%. They are just writing out of 60. And it's in most cases whereby you might not apply all the information that you know. That is why one would get maybe a 39% out of 100%. What could be the reason is because they went into exam with 60% worth of that, and they were only able to apply 39% of their knowledge. So with you guys, what we are hoping to achieve is that you go into your exam with at least 90% of the information. It's up to you what you do with that information when you get to exam. It's very painful, Moleboge, very, very painful to be writing an exam and seeing some things where it gets to a point whereby it feels like you are seeing those for the very first time. Imagine you're in grade 12 and they talk about axis of symmetry and you have never heard of that. Never. So that's what I mean by saying already you eliminate a certain percentage because you can't even attempt that question. Okay, so 4.2, what are they saying? Sketch the graphs of f and g on the same set of axes. So, Mzozozo, kahle kahle bathi, I'm not sure what is to dish out in Zulu, or is it Pagela or Hamisa. They are saying save F and G in the same plate. That's what they mean them zokuthi le phuthu leyo ne gravy on the same plate. And most importantly, clearly showing all intercepts with the axes, turning points, and asymptotes. So now, on the same set of axes, do your that and again your that if it's doing that. So can you see they've mentioned to say you must show the turning point, which means for you to successfully show those, you can score yourself 2 marks. They've also said show asymptotes. Asymptotes. Can you see? If you don't know what asymptotes are, you lose those 2 marks. And again, they are saying the intercepts with the axis. If you do not know what are the axes, you lose those 2 marks. So can you see? Marks come from you knowing exactly what they want you to do. They're giving you some light there to say, if you can trust the turning point, that means you must know what a turning point is. If you can maybe do, what is it, asymptotes, the ghost Cartesian plane, if you can correctly show that, we'll give you 2 marks. Intercepts with the axis Bantubakiti. That is where your graph touch the x and the y lines, which is at that point there, at that point there, also at that point there. This function touches those. Also at this point, can you see this is where that one, it touches that. If you can show those, we're going to give you marks. But can you score marks if you don't know what that is? If you don't know what, you obviously won't. So that is why I'm saying in these lessons, that's where we make sure that you know what you need to know. If you miss this lesson because grade 10s are in this lesson, when we start solving for questions, there won't be a time to explain what an asymptote is because it's already explained. Even in your class, you will sometimes hear your teacher saying, we are not going to do those because they taught you in grade 10. That's what they are referring to. They don't want to fall behind on their syllabus. So make use of these lessons as an opportunity for you to refresh the information in grade 10 and 11 if you are in grade 12. So we will also sketch tomorrow when we start to work out that. 4.3. Now I can say I did not talk at all about the range. And this is what happens. Mbali, assuming that you are hearing this word for the first time under this chapter, it feels like it's something complicated, but it is not. The problem is you were never told about the range. That's why it feels like it's complicated. But there is nothing complicated. It is not complicated. It's just that it was just not explained to you. That's what I mean when I say there's a possibility that you can go to exam with 70% worth of knowledge. Whereas the reason why we teach you is so that when you get to your November examinations, you go there with 100% worth of information. But in our lessons, by June, all of you guys should be able to attempt a November exam paper. After June, what we do is just revision. So that means when June comes, say July, we'll be talking about everything that you already know. That's if you attend all the lessons. And also, if you miss those lessons, it's fine, but make sure that you catch up. So the range also, easy, 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 easy. You will know what the range is if you know what the turning point is. It is easy as that. So you know your function is either like that or like that. If you know the y value of that turning point, then it means you know the range. That is why it is given 1 mark. You will learn about that tomorrow as we answer those questions. 4.4. They say determine the maximum value of h if h of x is equals to that. Moleboch, this is what I was trying to explain when I was saying as a chess player, it does contribute to your thinking. Can you see, in the beginning, they spoke about the graph of f and the graph of g, but all of a sudden, they are now talking about h of x. And at the same time, I don't even understand what they mean when they say the maximum value of h. Ungena phu h manje. ngoba azange basixelele ngo-h. Jiki determine the maximum value of h if h of x is equals to I'm not going to bother myself about that, but this is what I would do. Moleboge, where I see f of x, I can just substitute it there and see where that takes me. I'm just giving you an example in terms of sometimes how one can go about this type of questions. It may be difficult. You might not be understanding something, but just to try something, you can just maybe do something similar to that. Why are you doing that? It's because where you see f of x, you just substituted that. Even though you don't know why, but I'm telling you, somehow you might score a mark there. So that's what I meant when I was saying there were some questions which I did not understand at all, but I was able to do something because I've done a lot of questions and I've noticed how they work out those questions. For the sake of time, let me quickly skip that and quickly move on to this last one. So again, we'll just quickly discuss that. Remember, guys, we are not solving anything. That is why I'm giving you guys less time. If you thought you were going to talk today, it won't be the case based on the nature of the lesson. It is tomorrow where we'll be talking some more, which means tomorrow I won't be explaining what is what, but you will hear me frequently saying, in case if it feels like it's confusing or you feel like you're a bit lost, you will need to catch up. So that is why it is very, very much important, Bantu Bagiti, that you catch up. Because if you don't, it becomes, this is what they mean when they say something it's drawn not to scale. It's something of this nature where it's supposed to be a straight line, but it behaves like it's drunk. Have you seen a line that behaves like it's drunk? We try to make it a straight line, but for some reason, it's working somehow. Let's see what's happening there. We are also having that. I hope you guys are able to see where that information is coming from. So it looks a bit complicated, but trust me, it is not. Once you get to a stage where you are able to know what is what, you are very much closer to understanding this chapter. This is what I mean by what I'm saying. Let me not go to the questions, but try to interpret quickly what's happening there. This is what is happening, guys. You have, number one, a Cartesian plane having the x and the y axis. Number two, you have a straight line of which is given the name g. Y is equals to mx plus c. That is the general formula. And also you have this function called f. And the name of f is, or let's say the type is hyperbola. That one of a over x, maybe plus p plus q. So that means you're dealing with a straight line and a hyperbola on this question. Most importantly, you have a point being point A having those. Those are the coordinates. You have y is equals to negative 1. Someone might be wondering, what exactly is that? If you were listening when I was talking about what we call the ghost Cartesian plane or an asymptote, that y is equals to negative 1, it's actually that line. It means it's passing through there where that is negative 1. So that means already you are able to see that the function is actually a over a x, and then here you have minus 1. Where is the asymptote for that? it's possibly 0, meaning it's hidden inside there. That is why you can't see the vertical asymptote. If you can't see it, it means it is hidden inside that solid line. It's broken inside, but because of that solid line, that's why you can't see it. So that means actually here is plus 0. So if they say the coordinates of your asymptotes, the coordinates are written in a form of x and y. So your x coordinate is that, and then your y, that is that. So that is why y is equal to -1, and then x being 0 there. You also need to be aware of that. So with this type of questions, they might say, calculate the length from letter B to letter E. So those letters, guys, they are not just there for decoration. We don't decorate in maths. If it's B, if it's letter E, there's a reason why there's that letter. They're going to ask you questions based on that letter. So just make sure that everything given, you use it. Everything given, you use it. There's no way they can give you maybe a point there and call it a point K and never ask you questions based on that. There's no way. If it's not there, they won't ask about it. But whatever that is there, they will ask about it. If they don't ask about it, it means it's there to help you find something that you will use to answer the question. So I hope all of you guys did collect what was explained in today's lesson. So Mzozozo, tomorrow we will be solving for these questions. If possible, I will look for some more. Most importantly, we might be going for an extra time similar to today's lesson. The reason to that is because by June, we must be ready, guys. By June, we must be able to write paper 1 and paper 2. So that starting July, we just do revisions. So that's how you prepare for distinctions. Most importantly, we can't guarantee you a pass. Even your teacher cannot guarantee you a pass. But what we can guarantee you is that we will at least give you 90% worth of knowledge that you will need to use in the exam. It's in most cases where, especially some of my learners from last year, they get bored when I do these lessons. To someone, it might look like it was informative, but to me, also to those who have been attending my lessons since last year, they might be bored wherever they are because they already know everything. And they know that it is still going to get deeper. So they're just attending to prepare for those days. So just make sure that you are not falling behind. You catch up, you revise, whatever that was explained. If you don't understand it, you ask. So I think before I close our lesson for today, let me give anyone an opportunity to ask in case if there is something that I've explained of which they just need a clarity on that. Anyone who's got a question or would like for something to be quickly re-explained before Mzozozo allows me to sign out. I'm sure you guys are not watching Gomorrah there.
Minyera.
Yes.
Yes, Alex here. Can you please go back again to the asymptote, the Cartesian plane? Just the explanation is fine.
On hyperbola.
Yes, because the time you were explaining, there was that blocking,
Breaking.
stammering. Yeah.
Okay. I agree with you on that one. Let's say, I think this is going to make it easy. Let's say we have 2 over x, and then let's say we also have y, it's equals to, let's say, negative 3 over x, negative 1. Let's say again, we have y, it's equals to negative 3 over 2, all of that divided by x plus 2 minus 2. And then maybe the last one, let's say y is equals to, maybe let's say 3 over x, and then let me say plus 3. Yes. Let me try to explain the asymptotes on each of those. But most importantly, in your mind, you should know that you are having y is equals to a over x plus p plus q. This is the general formula of a hyperbola. Most importantly, we say the asymptotes, let's say equation of asymptotes, it's actually this p with its opposite sign and that with its original sign. P opposite sign, q original sign. Original sign. Remember, those signs is just positive or negative. Those are the only signs that we are referring to. So let's see, on that first one, what are the equations of asymptotes there? That is what the question will be, and it will be allocated 2 marks. So you need to know that this is where you get your equations of asymptotes. For that one, that means it's actually y is equals to 2 over x plus 0 plus 0. So that means, can you see this value which is closer to x, it is the one being the x asymptote. So you just say x is equals to you can say 0. Even if you say negative 0 because it's positive 0 there, positive 0 or negative 0 is the same. That's why I'm going to say 0. This one, you take it as it is. So that means it's going to be y is equals to 0. Those are the equations of the asymptotes of that one. How do they look like on a Cartesian plane? Cartesian plane, you're having the x and the y, and this is the origin where x and y is 0. So that means your asymptotes are actually hidden inside there, because this is where that one of y is 0 is the horizontal one. The y for 1, it is the horizontal. This one, it is the vertical for x. So that means the one for vertical is also hidden inside there. Why are we not able to see? It's because the x-axis itself is a solid line. That's why you won't be able to see that hidden that. So now let's quickly have a look at another function, being this one. So let's see. X is equals to y is equals to, those are the two equations of us. We know this one, it is the vertical, this one is the horizontal. So let's see there, can you see we are saying this one closer to x, it is the one that you write with its opposite sign. If it's negative, then you write it as positive 1. So here, can you see there, we are having nothing, and we said nothing in maths is 0. That is why I'm going to say that one for y is 0. How do they look like on a Cartesian plane? So that means, let's see, this one of x, can you see it's going to pass where x is 1. So you are going to show it there. And then this one is where that is 0. That's why you don't need to draw anything. Why? Because you know it is hidden inside there, where this thing is 0. It passes through the origin. Let's have a look at that other one. Now I'm also confident that it makes perfect sense. So on this one, when we talk about equations of asymptotes, you know we're talking about the x and the y. This one being the vertical, this one the horizontal. So let's see. Can you see? This is where you get the x asymptote, and we say you write it with its opposite sign. Can you see? There's positive sign, so that means it is negative 2. That one for y, you take it as it is. with its original sign. How does it look like on a Cartesian plane? Bantu bakithi, we're having x and y. Let's see, where x is -2, it's going to be there. You're going to plot it. Another one where y is -2, then that means it is going to be there. If you have 2, plot it. Then after plotting the x and the y asymptotes, that's when a hyperbola comes in. So can you see the a value now is negative, and if it's negative, you know that it's going to be in there, and also it is going to be in that quadrant. So in short, it's more like asymptotes. They actually shift the graph. So that means those asymptotes, this asymptote, which was hidden inside, it actually shifted 1, 2. And then this one, which was hidden there, it shifted 1, 2. That is why our hyperbola, it is no longer there and there, but it shifted towards this side. That is why I'm drawing it somewhere there. It's either it goes there or it crosses that, but it just gets closer to the asymptote. You will understand that better when we sketch. But for now, remember, I only need to make you aware of how you extract the asymptotes on an equation. So let's say vertical, horizontal. This is your x, this is your y. So let's see. For this one, can you see? It is 0 there. It's nothing there. That is why you're saying the one for x is 0. This one, you take it as it is with its sign. How does it look like on a Cartesian plane? So you will realize that at all the times, a Cartesian plane is necessary to. So now, this one, the vertical asymptote, can you see it's going to be hidden inside there? Why is it being hidden? It's because it has to pass through the origin where x is 0. Because we know at the origin that's where x is 0 and y is 0. That's why it passes through there. And because the y-axis itself, it's a solid line, it is hidden. So what about where y is 3? So that means you're having 1, 2, 3. So this is where you are going to plot your horizontal asymptote. Then if you had to sketch that, you would know that because your a value is positive, that means it is going to be in the first quadrant and also that quadrant. So that means this function, it actually shifted by 3 units upwards only. That is why that asymptote shifted 1, 2, 3. But this one, it shifted horizontally by 2 units and then vertically by 2 units also. Forget about the sign. I'm just trying to explain that this 2, it means it's going to shift in which direction? 1, 2. And then this one, it's going to shift 1, 2. That's what that is. So for this one, it means it won't shift in that direction, but it will shift -1 in that direction. Here, it will not shift at all. That is why it will be drawn where? Here and also there. How do I know there and there? Because A is positive. If A was negative, it was going to be there and there. And because here you're having 0, you're having 0. They are hidden inside. It means it is not shifting. I'm not sure. Alex, did that make sense, honorable member?
Yeah, it's getting in. I'm catching up. Yeah, thank you.
Bonolo Mathule, endinako sifumba. The Maumis, are you sure you guys don't have any question before I sign out?
No, thank you,
Quite
sir.
dark. Make sense.
Yes.
Makes sense.
Okay, guys, thanks very much for joining. My name is Desmond, and I'm out.